Hello, darlings. So here we are in Unit 3, Section 3.4. We are going to be solving absolute value inequalities. So we just finished talking about how do we solve those absolute value equations. So it's really going to be a similar process. Instead of an equal sign, we will see one of our inequality symbols. And so, of course, I want to start off with graphing these just so you can get a visual of what our answers are going to be looking like and how they're going to be set up. So we are solving the inequality by graphing, and we're going to write our answer in inequality and interval notation. Okay, so just the same with equations, we are going to graph our absolute value on the left, and then we're going to graph that horizontal line on the right-hand side. So on the left-hand side, we see the absolute value of x minus 2 minus 1. So that means I have shifted to the right 2 units, and I've shifted down 1 unit. So my new vertex is at 2, negative 1. This absolute value has not been stretched or compressed. It hasn't been flipped. Therefore, it still has that slope of positive 1 and negative 1. And so I graph that absolute value, and it looks something like this. Ooh, okie dokie. That's off a little bit, but all right, so there's the left-hand side graphed. So when I go to graph the right-hand side where it says 2, we know that that is a horizontal line going through 2. We want to know, where is our absolute value graph, where is the blue graph greater than that line? I'm trying to find a good color. Let's go pink. Where is it greater than 2? So where is our blue absolute value greater than or higher than that yellow line of 2? Well, here and here. And so if we had to write that in interval notation, then we would be writing that as all those negative numbers, so negative infinity all the way up to that number of negative 1, not including it though because of my symbol. It's just greater than. It's not greater than or equal to. And I also see it from the number 5 all the way to infinity. So I have 2 separate areas where my absolute value graph is greater than 2. So this is what it's going to look like in interval notation. In inequality notation, I'm saying that it's all the x's that are less than 5. Or, if you think about it, it's 2 things. Or it's all those x values that are greater than, I did the wrong number here. Sorry. X is less than negative 1, and then x is greater than 5. So that would be what my inequality looks like. And then that would be the interval notation of those 2 separate areas where this is a true statement. Okay, and so we could also see it where it's not 2 separate areas, but maybe it's just 1 area. So we'll go and look at part B. So I'll do the same thing. I'm going to graph what's on the left, and then I'm going to graph what's on the right, and we'll see where this statement is true. So absolute value of x plus 1 plus 2 means that I've shifted my absolute value graph left 1 unit and up 2 units. Therefore, my new vertex is here at negative 1, 2. Hasn't been stretched or compressed, hasn't been flipped. So again, that positive and that negative 1 slope on either side. Okay, so here is my absolute value graph, the way that it's been transformed. Then I want to graph what's on the right-hand side, which is a horizontal line of 3. So that horizontal line of 3 is right here. And this time, I want to know, where is my absolute value graph less than 3? So where is it below that blue line? So obviously in this vicinity here. So if I was writing that in interval notation, then that would be all of the x's between negative 2 and 0. Not included again because of the symbol. It's just the less than. It's not less than or equal to. So from negative 2 to 0, those are the x values where it is less than that horizontal line. I also want to write this in inequality notation. This is going to be a compound inequality because I have x's that are less than 0 but greater than that negative 2. And so this is just, like I said, just 1 area where it's a true statement. Over here, there was 2 areas where it was a true statement. Okay, and so that brings us to kind of a little hint, tip, trick, whatever you want to call it. But When your A value is positive, so when you get our absolute value being greater than a number that's positive or an absolute value that is less than a number that is positive, we're going to see some things happen. And so that's whenever we get into solving algebraically, which is what we're going to do in example 2. Okay, here we go. Just like what we did with the equations, we're going to follow this step-by-step process. Our first step is still isolating the absolute value. The second step is creating two inequalities, just like we set up two equations. And then we're going to actually graph it on a number line to be able to write our answer in interval notation. Okay, so here we go. First step is isolating the absolute value. So in order to do that for part A, I would need to add 7 first. So then I get 3 times the absolute value of x plus 1 is greater than or equal to 6. Negative 1 plus 7 is 6. The second thing I need to do is divide by that 3. That's going to leave me with the absolute value of x plus 1 is greater than or equal to 2. I have isolated my absolute value. Therefore, I am moving to the next step, which is to create the two inequalities. Just like we did with equations, I'm going to do a positive where I just drop the absolute value signs and keep everything the same. And then I'm going to do the quote-unquote negative. That means I've dropped the absolute values and everything on the inside of the absolute value will take the opposite sign. So instead of a positive x plus 1, I'm going to take a negative x minus 1 and still leave it greater than or equal to 2. I'm not changing my sign. I'm not changing the number on the other side. I'm only changing what's inside the absolute value to create those two equations. And so now I solve. And so over here, I'm solving for x. I get x is greater than or equal to 1 by simply subtracting the 1. Over here, I need to add the 1, so I get negative x is greater than or equal to 3, but I don't want negative x, I want x by itself. Remember with inequalities, when you divide or multiply by a negative number, your sign will flip. So when I divide by this negative 1, I'm going to get x is less than or equal to negative 3. So these are my two inequalities. So what I want to do is I actually want to graph it on a number line. So I'm just going to quickly sketch a number line. I know that negative 3 will be on the left and 1 will be on the right. Looking at my symbols for the x is greater than or equal to 1, that means at 1 I have a solid dot and I want all the x's greater than that. So that's everything on the right-hand side. X is greater than or equal to 1. Solid dot at 1, shaded everything to the right. For x is less than or equal to negative 3, at negative 3 I also have a solid dot, but I want all the x's less than that, so that's shading to the left. And so I have these two areas where my graph or this statement would be true. So how do I write that in interval notation? Well, that means I want all the values from negative infinity up to negative 3 and including that value because it's a solid dot, and I want the 1 all the way to infinity. So whenever we have our absolute value isolated and it's greater than or less than or greater than or equal to or less than or equal to a positive number, we are going to get two scenarios. When our absolute value is greater than a positive value, we get this OR statement. Look right here. We have the absolute value of x plus 1 is greater than or equal to 2. Or means I'm getting two areas where my solutions could be. That's what I was getting here on the number line and here in interval notation. It's this part or it's this part. It's from negative infinity to negative 3 or it's from that 1 to infinity. So this is giving us an OR statement, greater than or equal to. Okay, that's a good way to remember it. If we get an absolute value less than some positive value, then that's going to be an AND statement. That's going to be like what we saw up here. This is an AND, this is an OR. Okay, and because it's in one location, it's between this and that. Or it was here or it was here. So for this one, let's see what happens. So first step is always to isolate the absolute value. Let me change colors. Isolating the absolute value. First thing I would need to do would be to subtract the 6. So I'd get negative 2, absolute value of x plus 3 is greater than or equal to -2. The second thing I need to do is divide by -2. When I divide, I'm going to divide by that negative. I'm going to switch my sign. So dividing by the -2 leaves me with the absolute value of x plus 3 is less than or equal to a +1. So I want to stop right here and I want to reflect because my absolute value is now isolated. I have an absolute value less than or equal to 1. That's this scenario here. An absolute value is less than a positive number. So it's going to be an and statement. So you'll see that once we continue to solve this problem and graph it on our number line. So I'm still following my process. I've isolated the absolute value. So the next step is to create two inequalities. So drop the absolute value. I get x plus 3 is less than or equal to 1. Drop the absolute value, make what's on the inside opposite. Negative x minus 3 is less than or equal to 1. Solve for x. X is less than or equal to -2. And then negative x, 4, divide, switch the sign, -4. Okay, so here are our two, inequalities. So I want to sketch a number line and see what this looks like. -4 is on the left, -2 is on the right. Both of them are going to be solid dots because it's a less than or equal to and a greater than or equal to. So when I have x is less than or equal to -2, I would be shading to the left, and then I would keep going. And then for x is greater than or equal to -4, I would be shading to the right. So where are they both overlapping? In that middle area. Let me do another way of graphing this with some colors so you can see. So here's our number line. We have the -4, we have the -2. Let's say I'm doing this one in yellow, and let's say I'm doing this one in this blue color. Okay, so, oh no, sorry. So if I have the yellow, I want x is less than or equal to -2. That would be a solid dotted -2, and everything would be shaded to the left, right? If I go to that blue color and I want to shade x is greater than or equal to -4, it would be a positive circle at -4, and it'd be everything to the right. So where do I see the blue and the yellow together? Where is it true for blue and for yellow? In that middle region, which is from -4 to -2. This is that and kind of statement or solution. So this is a or, and then this is an and. And it makes sense because it's easy to remember. Greater is going to be an or. Less than is going to be an and. So that's an easy way to remember it. You still want to follow this three-step process of isolating the absolute value, setting up your two inequalities, and then writing your answer in interval notation. Always graph it on a number line first. And then that way you can see where the shading overlaps. And then it should just confirm if it's an or an and type of answer. Okay. So that's for whenever it's the absolute value is isolated, if it's greater than or less than or greater than, less than, whatever, a positive number, if A is positive. Well, what about when A is negative? So let's look at those two scenarios here. So what if you get an absolute value isolated and it's greater than a negative or it's less than a negative number? Let's see. So I'm going to follow my three-step process. First step is isolate the absolute value. To do that, all I need to do is subtract that 4. So then I get this statement. Here I'm going to pause and reflect. I have an absolute value being less than, or where is it less than a negative number? Well, we know the properties of absolute values, and we know that absolute value of anything is always greater than or equal to 0. So where is an absolute value going to be less than a negative number? Nowhere. This is not even possible. Therefore, not possible. Therefore, no solution. No solution here. When you get an absolute value less than a negative, that's never going to work. And you could even graph this. Think about what that would look like. You have some absolute value graph. Maybe it's over here. And then you have a -5 down here. Where is this V less than that -5? Nowhere. Nowhere, nowhere, nowhere. Okay? It's not possible. All right, so let's look over here and see what happens. I have the absolute value of 2x plus 1 plus 4 is greater than -1. So again, I need to isolate my absolute value. So absolute value of 2x plus 1, subtract that 4 to isolate, and then I get this. So then it's saying, where is the absolute value greater than -5? Well, absolute value is always going to be positive or it's equal to 0 or greater than 0. So it's always going to be greater than -5. A positive will always be greater than a negative, right? So this is always true. Therefore, this is going to be all real numbers. And again, you can think about that on the graph. If I sketched a graph of this, where is my absolute value greater than that negative number? The whole entire thing is greater than it, right? So these are a little bit easier. You don't have to do as much math if you can recognize when you get that absolute value isolated, if it's less than a negative number, that's going to mean that there are no solutions. Okay, go ahead and write out that whole word. No solutions. Okay, and then if we have an absolute value isolated and it's greater than a negative, that's always going to be true, right? This is all real numbers. Or if we write it in inequality notation, interval notation, that would be from negative infinity to positive infinity. Okay. Let me make this a little bit smaller. Because our directions did say to write it in interval notation. So this was my final answer here. This was my final answer here. Okay, interval notation. So pay attention to when that absolute value is isolated. If it's greater than a positive number, you'll know what kind of answer. If it's less than a positive number, you'll know what kind of answer. If it's greater than a negative, you'll either know it's nothing or everything, or if it's less than the negative, et cetera, et cetera. All right, so this would be a good time where you could pause and try some, actually, know it. Let's do E and F together first because they're a little special. And then at that point, that would be a good point to pause the video and try some of these on your own. But let's do E and F together first because, like I said, they give us a special scenario. So let's go with this pretty color. All right, so I have absolute value of x minus 4 plus 3 is greater than 3. First step is to isolate the absolute value. I'm going to do that by subtracting my 3, and that's going to give me this situation here. And so I need to pause and reflect at this moment. I have an absolute value greater than 0. That is pretty much always true. And the reason why I say pretty much always true is because the property says that an absolute value of anything is always greater than or equal to 0. And so we're missing that equal to symbol there. If the equal to symbol would have been there, this would have been an always and we're done, right? It would have been this and we're done. Final answer. But it's not there. So we need to think about this is pretty much true all the time except when this absolute value of x minus 4 is in fact equal to 0. So this is true always, true except for when that absolute value is equal to 0, right? We don't want it to equal 0 because that's not what the problem is saying. So if we said this where it's not equal to 0, then that means I have x minus 4 not equal to 0. Not equal to 0. So that means x can't be 4. Because when x is 4, my graph is not greater than 0 because it's equal to 0. Think about graphing this problem. Absolute value of x minus 4 is an absolute value that's been shifted to the right 4 units. This vertex is 4, 0. So when x is 4, my graph is not greater than 0 because at that x value, it's equal to 0. So this is true. This problem is true everywhere for except when x is 4. So how do we write that in interval notation? Well, it's everything up until 4, not including 4, and from 4 onward to infinity. Everything but 4. So this would be like inequality notation, and then this is your interval notation. So it's a special case. You got to be careful for that. All right, it's kind of similar over here. So let's look at this one. It says negative absolute value of x minus 4 plus 3 is greater than or equal to 3. So isolate the absolute value. First thing is I need to subtract the 3. So that gives me here. When I divide by that negative, I'm going to switch my sign. I know that it doesn't affect the 0, but it does change my sign. Okay, so now I have this. So let's think about this case. It says, where is the absolute value of x minus 4 less than or equal to 0? Let's think about if that would have been our problem, where is the absolute value less than 0? That would have been nowhere, right? Our absolute value is never going to be less than 0 because that means it would be negative, and that's not true. But we have that equal sign there, and we know that an absolute value can equal 0. So this is only true. So this is actually nowhere except when x minus 4 does equal 0, which means that's when x is 4. That is our only answer. That's the only thing that's going to make this true. Again, graph that out. This is an absolute value graph that has been shifted right 4 units. So my vertex is 4, 0. Where is this graph less than 0? Nowhere. Where is it equal to 0? Right here at 4. So where is it less than or equal to 0? Only one location. X is 4. Technically, if you wanted to write that in interval notation, you can put something like this. Brackets 4, because you are including that value and it is just one value. Okay. So like I said, these are special. You're not going to see them happen very often, but they can occur. So just be aware of those kinds of things. It's really good to, once you get that absolute value isolated, just kind of take a step back and reflect and ask yourself, okay, can an absolute value be greater than a positive number? Can it be less than a positive number? Can it be greater than a negative number? Can it be greater than 0 or equal to 0 or whatever? Just kind of talk it out. You guys should know your properties well enough by now to kind of figure those things out. Okay, so you've gotten kind of a taste of everything that could happen. So like I said, this would be a good time where you could pause the video and work out these problems kind of on your own. But I'm going to keep working. So here we go. So first step, like I said, isolate the absolute value. So be careful here. My first step is not dividing by -2. My first step is not taking 3 and minusing 2. I have to subtract that 3 first. So I get the -2 absolute value of x minus 3 is less than, if I subtracted that 3, then I would have gotten a -8 here. Dividing by -2 is going to change my sign, give me that +4. So now I take a step back and I think to myself, the absolute value of x minus 3 is greater than 4. Okay, so that could be true, right? And because it's a greater, we know this is going to be one of those or scenarios. So I'm going to have kind of two answers. It's going to be here or here. So next step, I create two absolute value inequalities, or two inequalities. X minus 3 is greater than 4, negative x plus 3 is greater than 4, and I solve like normal. X is greater than 7, negative x is greater than 1, divide, change the sign. Here we go. At this step, I'm going to graph. Okay, -1 would be here, 7 would be here. Both of these are going to be open dots because it's just greater than or less than. X is greater than 7 is going to be all of these. X is less than -1 is going to be all of this. That confirms that it is an or statement because I am seeing from -infinity all the way to -1, not including, and then 7 to infinity, not including that 7 either. Okay, so when you have an or scenario, you are going to be using that union symbol because it's going to be in two locations that it's true. Okay, let's do it again. Let's go hot pink. All right, isolate the absolute value. So I have 2/3, absolute value 3x minus 2. Adding the 5, I get 4 here. And then I have to divide by 2/3, which is the same thing as multiplying by 3/2. So then I get absolute value of 3x minus 2 is less than 6. So 4 times 3 over 2. That would technically be 12 over 2, which is 6. You should be able to do that in your brain. All right, and so here we have our absolute value being isolated. It's less than a positive number, so we know that this is going to be an and, less than. All right, create my two equations. 3x minus 2 is less than 6. Negative 3x plus 2 is less than, 6. 3x, 8x, 8 thirds, negative 3x, 4x, switch the sign, negative 4 thirds. And so now I need to graph this on a number line. So I know it's going to be an and, so that means they're going to be overlapping. If I did everything right, a negative 4 thirds would be on the left, a positive 8 thirds would be on the right. These are going to be open circles because they're less than and greater than. So if I want x's less than 8 thirds, I would be shading to the left. If I wanted x's greater than negative 4 thirds, I'd be shading to the right. So where they overlap is in this middle region. So that means my interval answer would be negative 4 thirds to 8 thirds. Okay, kind of nice that we don't have to plug these numbers back in like we did for equations. We just have to graph it on a number line and make sure we're getting those intervals or interval correct. All right, going on to I. Our absolute value is already isolated, so we can jump in and create our two equations. Now, we don't know what x is equal to, but we know that because that it's an absolute value, we're hoping that it's going to be a positive number on that right-hand side. So let's just create our two equations and see what happens. So we would have a 2x minus 3 is less than x plus 1. And then we would have a negative 2x plus 3 is less than x plus 1. So solving, I would maybe subtract my x, add my 3, so that would give me x less than 4. And then over here, I would add my 2x and subtract my 1. So that's going to give me a 2 is less than 3x. And so then that means x is greater than 2 thirds. All right, so then, and you could solve that obviously multiple ways, but so then I need to graph it on a number line. So I have 2 thirds and I have 4. Both of them are open dots because it's just a less than or a greater than. So then when I go to shade, I want x's less than 4, so I'd be shading to the left, and then I want x's greater than 2 thirds, so I'd be shading to the right. So they are overlapping here in this middle region. So from 2 thirds to 4 is my interval answer. Okay. Now over here, let's look at this. We have an absolute value greater than an absolute value. So technically, the first step is to isolate the absolute value. Well, one of them is already isolated. I know the other one is not, but to isolate the first one, then the second one wouldn't be isolated back and forth. So as long as one of them is isolated, we are good to go. But let's think about what we have here. We have negative 2 times the absolute value of something is greater than the absolute value of something. We know that absolute values are always positive, right? Positive or greater than or equal to 0. If I have a negative 2 times a positive something, will that be greater than a positive something? Well, negative 2 times any positive number is going to be negative, and negative cannot be greater than a positive number. This is not possible. Therefore, no solution. Now, if this would have been a positive 2, then I would have created my equations and went with it and, graphed a number line and checked it, et cetera, et cetera. But my absolute value is always going to be greater than or equal to 0. Negative 2 times a positive number is going to be a negative number, and a negative is never going to be greater than a positive. So this is not possible, so no solution. All right, keep your eyes peeled for those situations, guys. All right, and then of course we have some word problems, very similar to what we did with the equations. Some of these, you're going to be able to read the question and know the answers immediately. That's not the point. The point is, can you read the word problem and create an equation or an inequality to represent that situation? And so I think the bell's about to ring, so if you hear a buzz, I apologize, but I'm almost done, so I'm going to keep going. A machine cuts boards that are 3.25 meters long. The boards are not perfectly cut each time, so the company sets an allowable amount of error of 0.02 meters. If the board length differs by more or less, it is thrown out. Write an absolute value inequality and solve it to find the range of acceptable lengths. There it was. I apologize for that. So what we need to think about is 3.25 meters long is our goal, right? That's going to be what you can call kind of the midpoint. The variance, that amount of error that we're allowing, is 0.02 meters longer or 0.02 meters shorter. So that's your variance. That's your wiggle room, okay? We need to set up our inequalities in our equations such that we have the actual length, what that variable is standing for is the actual length of the board, minus our midpoint. In this case, it is the exact length that we want it. Our amount of error, our variance, is that 0.02, and we said we have to be less than or equal to that amount, because if it's more than 0.02 meters longer, it's thrown out, or if it's more than 0.02 meters shorter, it is thrown out. So we need to keep this number less than or equal to that variance of 0.02. And so this is our equation. And so from there on, you know how to solve. You're creating the two equations. And we're just solving. So for this one, we would get x is less than or equal to 3.27. And then for this one, we would get the negative x less than or equal to a negative 3.23. Whoops. Dividing, change the sign, boom. Which is something that you probably could have guessed or, figured out just by reading it. But this is the important part, okay? So it's absolute value of what you're actually representing minus kind of that middle, or the exact thing that it needs to be, and then either less than or greater than, less than or equal to, greater than or equal to, that variance, that wiggle room. So let's do the last one really quickly. So it says, the weight of a healthy newborn baby can range from 5.5 pounds to 10 pounds. Okay, I was close to a 10-pound baby. I was a big baby. It says, write an absolute value inequality to show the possible weights of a newborn. So what they give us is actually the range that this newborn baby could be. So we need to find that midpoint, which will then give us that variance, okay? So the midpoint between 5.5 and 10 is 7.75 pounds, okay? Hopefully you know how to find midpoint. Add and then divide by the number of things that you're adding. For midpoint, it would be 2, obviously. So following that suit, we would have the absolute value of the actual weight minus 7.75, which is our midpoint, and that's going to be less than or equal to, what's the variance? So if 7.75 is our middle, we can go to 5.5, and then we can go up to 10. So what's that variance on either side? It's 2.25 pounds. So this would be our equation, okay? This is saying the actual weight of a newborn baby minus 7.75 pounds could be less than or equal to 2.25. And when we solve, that's where we get that minimum of 5.5 and that maximum of 10 pounds, all right? So actual weight, actual length, actual whatever measurement we're talking about, minus the midpoint, absolute value of that, and then either greater than or equal to, less than or equal to, greater than, less than, the variance or the wiggle room, quote unquote. All right, see ya.